Hi there. I've just got a little bit more to say about the fetch, decode, executes cycle by way of explaining the operation of this cycle in a little more detail than we've covered. If you remember, we're going back to topic 2, week 2, when we learnt what it was for a computer to be able to execute a computer program. So we start off by simply looking at, let's just make sure I can scroll through this document. We're looking at the diagram slightly revised that we were confronted with in week 2. Here is main memory. Here, this rectangular box is the CPU unit, which contains, as you can see, the ALU, the arithmetic logic unit, together with the accumulator register, which is connected to the ALU in this way. And secondly, we have what we described as the controller, the CNTL, or the CNT. And this component consists of two other components, the program counter and the instruction register. And the main essential component is the actual controller. And the key idea is that the controller is actually going to be fed with the binary representation of an opcode, and the system is such that the controller is going to take the opcode, for example, the opcode for addition, and the controller will then know how to perform an operation. For example, it's actually going to send a signal back to the ALU and perhaps actually moving some data into the unit, whereupon the contents of the accumulator are going to be added to the data that's just arrived. The ALU will do the addition and place the results back for safekeeping into the accumulator. So what I want to do is just to have a look at the fetch execute cycle a little bit more. And if you recall, one of the instructions that we looked at, it's very simple, and it's just move followed by an address. And the idea is that whatever is contained in a memory address called address, it's going to be shunted into the accumulator within the CPU unit. So it's just a data movement. What we're doing is to move the data at a particular address into the accumulator. And supposing this instruction is held at the memory location memlock. So I'm thinking about a specific instruction which is simply saying move data to be found in this address into the accumulator register. Supposing this instruction is itself held in main memory at a location, let's call it memlock. So how is that going to be fetched from main memory? Well, I'm going to show you. So first of all, memlock will be contained in the program counter. Remember, the PC, the program counter, contains the address of the next instruction to be fetched. The next instruction to be fetched. So the address is actually going to be routed, if you follow the cursor, routed into the address register. And as soon as that's happened, the the instruction register will actually contain the move instruction itself. So what we have so far is an address in this register, the address register, which I've nicknamed A, and in the instruction register we've got the binary representation of the MOV, the move instruction. So the move instruction is going to be examined by the controller, and the control circuits will be activated in such a way that it's going to send main memory a read instruction, and a short time afterwards the memory is going to be read at the address contained in the address register, which we agreed was memlog, and what comes out is the instruction held in memlock at that location. And if you recall, an instruction consists of two parts. First of all, the opcode, and the opcode in this case is going to be routed into the instruction register. So what am I saying? The symbolic name for the instruction is going to be placed in this register so that the controller knows exactly what it's got to do. And the address part, because all our instructions consist of two parts, firstly an opcode followed by an address. So the address part is actually going to be routed from this register into, guess what, the address register. So what the CNT, the controller, is going to do is to say, aye, we've got a move instruction here, therefore I'm going to send out control signals that will bring about the movement of whatever is contained at the location that's currently now in the address register. So for example, it's going to send out another read instruction, and the main memory is actually going to output the contents of main memory at that address. So it's going to be data, because we're moving a number from main memory into the accumulator. So the controller is then going to say it's going to take the data, perhaps it's just a simple integer, and it's going to route it into, guess what, the accumulator. And finally, the controller is going to say, okay, well, I've fetched some data. Maybe it's going to be added to a number already in the accumulator, but it's going to supervise all those little operations. Maybe it's first of all move the number that was in the accumulator into the ALU, and it's just moved some more data into the accumulator, and then that data is going to also go into the ALU, and finally the control circuit is going to issue, maybe it's going to be a subtraction operation. So one number is going to be subtracted from the another, and in addition the result is actually going to be then stored in the accumulator. Okay, so it's quite good. The diagram when you first see it looks quite complicated, but going back to week 2, what the diagram actually represents is a CPU module, a control module complete with 2 registers, and the main memory, and the data register, and the address register. And what we've just done is to look at the whole sequence of operations, and the sequence of operations that we've just seen occur is very typical. fetching some data from main memory, or maybe fetching the next instruction from main memory and dealing with it appropriately. So hopefully that's quite reasonable. So I've got some notes here, so read up about them and let me know if there's anything that still confuses you. And I think I'm actually doing it in stages. So for example, let me just steady this picture here. I think I'm doing it stage by stage, illustration by illustration. And here I'm actually pulling something out of main memory and putting it into the data register, and then so on and so on. So hopefully that gives you a little bit of an idea of the meaning of what's meant. So the meaning of the phrase fetch, decode, execute cycle. Fetching an instruction or data, decoding it by placing an opcode into the instruction register, allowing the controller itself to generate a sequence of signals that moves data about or tells the CPU module exactly what to do, and that's the execution part of the sequence. So hopefully you'll find that a bit useful, but don't hesitate in giving me a bit of feedback as to whether or not it's useful. If it's not useful, then we'll try going over this again. But I think there's a question on the assess coursework asking for a bit more detail about the fetch, decode, execute cycle. What is involved? Tell the examiner all about the fetch, decode, execute cycle, or give a little diagram and indicate what's happening by means of arrows, something along those